Hey everyone, and thanks for tuning in again. In today's video, we'll be covering how to transform non-normal data. So, normality in the dependent variable will often be associated with non-normal residuals, and this violates one of our regression assumptions. As a result, this yields problems for inference. So, to try and eliminate non-normality, we can try and apply transformations before an analysis. So what we'll do in today's lab is we'll examine the skew and kurtosis of the variables in the regdata3 dataset. This is the dataset that we used in the last video. If any of these variables exhibit relatively large values for skew and/or kurtosis, we will try applying two different transformations. First, the square root, and second, a log transformation. And we'll be using the natural log, which is the default in most software. After transforming our variables, we will check for improvements by recomputing our descriptive statistics, where we'll look at the skew and kurtosis values, and by visually inspecting the transformed distributions using histograms. Before we get started, just want to make a note on interpretations. Remember that the standard interpretation for a regression coefficient is the expected change in y given a 1 unit change in a predictor controlling for all other predictors. This changes when variables are transformed because the units of y have changed. So instead of speaking in terms of a beta unit change in y, we will now be talking about a square root unit change in y, or a log unit change in y. Because it's not just in the units of y, but it's now in the square root of the units of y, or the log units of y, or whatever transformation you may be applying to your data. So just remember that the interpretation will change and become a little bit more messy when you transform your variables. And with that, let's go ahead and get started with the lab. Alright, so I have SAS open here. And the first thing that we're going to do before we get started with transforming our non-normal data is we're going to read in our data set. So just as we've been doing before, we'll be using point and click to get in our regdata3 data set. And then just a note here, I have the week 8 underscore template SAS open. So let's go ahead and start with importing our data. So I'll go to import data. I'm looking for a tab delimited file, so tab delimited. I'll click next, browse for where it's located, and remember that I keep all of my data sets on the C drive in the folder named datasets, and nothing shows up because it's limited to .txt files, so I'm going to go ahead and switch that to all files. And then regdata3, the dat file is here, and so I'll open that. Click next. Let me give it a name, regdata3, and then I'll click finish. So regdata3 has 150 observations and 5 variables, and if I go into libraries, go into the work folder, take a look at my data set, x1, x2, y1, y2, y3, yeah, everything looks good, 150 observations. Same data set we worked with in the last video. Alright. I'll go ahead and turn the output delivery system to HTML. Go ahead and run that code. Okay. And then remember that this code here and this code here is to output all of our output at the end to a Word document. So remember, if you want to do that at the end, you just backspace here, backspace these two right here, and then if you run all of the code, so you would just highlight everything in between here and here, that would output it to a Word document. And remember, you just have to specify what folder. So here, the C drive in the datasets folder, which is where all my datasets are stored, and then you'd want to also specify here the file name. Okay. So I'll go ahead and comment that back out. Alright, so the first thing we're going to do here is we're going to compute our descriptive statistics. So I'm going to use proc univariate, My data set is reg data 3, and then I'll just press run. I won't specify any variables because I'd like to see the descriptive statistics for all of my variables. Okay, so I'm going to scroll to the top, and remember, we're going to look at skewness and kurtosis. As a rule of thumb, anything at plus or minus 3 for skew and kurtosis is something that we should be concerned about. For skew, sometimes the values lower than 3 can yield some problematic skewness, so maybe values around 1.2 or so. So for skew, we're looking at around 1.2, kurtosis, anything plus or minus 3, and anything below those we won't worry too much about. So for x1, these are pretty low, so we won't worry about those. x2, same thing, pretty low, nothing to worry about there for skewness and kurtosis. y1, skewness again, pretty low, kurtosis, same thing. y2, skewness at 1.27, so that's starting to get higher up there. And then kurtosis, clearly over 3, so we'll take note of this variable here, y2. And then looking at y3, skewness it's okay, and then kurtosis, that's below 3, so nothing to worry about there. So we're going to focus on this variable here, which is at most risk for violating normality. So we're going to focus on y2. Going back to our syntax file, let's go ahead and plot y2 and take a look at what it looks like. So proc univariate data equals reg data 3. I'm going to specify that the variable is y2, and I need to specify that I'd like a histogram, and then run. Now you may be wondering why I don't just include this up here when I'm running descriptives. When I'm doing my first sweep of all the variables, I don't want histograms for all the variables, so that's why I run these separately here. So now that I know that I want to take a look at y2, I'm going to request the descriptive statistics as well as a histogram. So we can go ahead and run that. And just as we saw in the last lab, it does look to be positively skewed with an observation out here, and we have this tail that is pulling toward the right. Okay. So maybe this gives us good enough reason to transform. So I'm going to show you how to do 2 transformations. We're going to transform using square root, and then we're going to log transform. So to do that, we're going to use a data step. So data, and then we're going to specify the data set, reg data 3. And then I want to set. So the data set that I'm starting with is reg data 3. And so that's what I type for the set statement. And then what we're going to have to do first, so if we go back to this output here, if we look at y2, the minimum value is, let's see, so we have negative values for y2, and the lowest is negative 2.92, the minimum right here. So what I'm going to do is I'm going to add a constant to every variable, and I'm going to shift the distribution so that there are no negative observations. Because negative values will pose problems if we're trying to take the square root or if we're trying to log. So the first thing I'm going to do is create a new y2. I'm going to call it y2 new, and this is going to be y2 plus 3. Since the minimum is 2.92, adding 3 to everything will make everything positive. So now that everything is positive, I can go ahead and take the square root of everything, which is our first transformation. So I'm going to call that variable y2 underscore root, and then I'm going to take the square root of y2 new. And be sure it's y2 new that we're taking, that we're putting in here, because we want no negative values, so we need all the values to be positive. And then next, I'm going to do y2, I'm going to take the log, so I'm going to name that y2 underscore log. And then I'm going to take the log of y2 new. So essentially what I'm doing here is I'm creating a, using my regdata3 data set. The new regdata3 data set is going to have this variable called y2 new, where I add 3 to everything to make everything positive. Then I'm going to have the square root transformed variable of y2 new, and then the log transformed variable of y2 new. So let's go ahead and run this. Let's see. So if we go back to our regdata3 data set, we now have 3 new variables. We have y2 new, and if you see here, 0.27, and the new value is 3.27, 1.61, the new value is 4.61. So we're just adding 3 to everything in this column, and that gives us y2 new. And then if we square root y2 new, we get this column here, and then if we take the log of y2 new, we get this column here. So now we have these added variables, which are the transformations. Okay, so what we'll do now is we'll check the skew and the kurtosis of our transformed variables. So I'm going to use proc univariate again. Our data is regdata3. And then the variables that I'm interested in are y2 root, and y2 log. Then I can run this. Now, just as a reminder, I printed out y2, so the skewness was 1.27 and the kurtosis was 4.404. So when we take the square root, when we transform using the square root, skewness is now close to 0, and kurtosis is all the way down to 2. So now that variable looks good. When we scroll down to y2 log, interestingly, it actually made things worse. So again, this is kind of a trial and error procedure. There are many transformations out there, and the goal here is to pick one that eliminates the non-normality of the variables that are problematic. So we're just going to go ahead and ignore the log transformation and focus on the root transformation. Okay. So we'll go ahead and plot our root transformation, which seems to have eliminated the non-normality most effectively. And so I'm going to use proc univariate. Our data set again is regdata3. And then the variable I'm interested in is the best transformation, which is y2 root. I'd like to print a histogram, and then we can run this. Okay, and yeah, so it looks pretty normal. And if we scroll up and look at our original plot, here's y2 originally, pretty obvious positive skew there. And so if we're worried that that will cause problems for the distribution of our residuals, then this should alleviate our worries here, because this is looking pretty normal. Again, the interpretation will change when you change the scaling of your variable. So if you take the root of everything, it's no longer in raw units of y2, it is now in square roots or it is now in the square root of y2. Okay, and so with that, that concludes this video on transforming non-normal data in SAS.